Good evening, students. Welcome to Advanced Physics classes. How are you all? Okay, so today we will discuss Coulomb's law. Yes, we have topic Coulomb's law. Okay, and this is also we can say Coulomb's law in electrostatics. Coulomb's law in electrostatics. Okay. In this topic, we will discuss the interaction of the two charges. Is it clear? Last classes we are discussing that how the two charges can interact and how the force can be experienced. Yes, yesterday I had shown the two magnets I had, and when we are bringing both the magnets, sometimes it is experienced repulsion and attraction also. And related with that, today we will discuss, you know that suppose that if you will take the positive and the positive charges, what will be the force? Can you say? Here will attraction or repulsion? Yes, here will be repulsion. Okay. You know that if there is a same charge, then it will repel. Suppose that if you will take here, suppose that minus and here is also minus. So what will be? They will also repel with each other. Okay. If you will take positive and here is negative, then and this will be okay. What here will be? It will attract with each other. Yes. Means in this case, according to Coulomb's law, what we can see, Coulomb's law states or it represents that whenever we take the 2-point charges, yes, you take the 2-point charges and both the charge, if you will place at a certain distance, you will notice that if there is the same charge, it will repel. If it is opposite or different charges, it will attract with each other. Okay, and you can see this one. Suppose that okay, these two charges we can join with their centers. Okay, so before these ones, what is the statement of the Coulomb's law? The statements of the Coulomb's law states that the 2-point charge, okay, charges attract or repel with a force proportional to the product of the magnitude of charges and distance, a square of distance between them, that you can write here. Suppose that you can write a statement first. Okay, it states that 2-point charges 2-point charges attract or repel each other with a force which is each other with a force which is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of distance between them. Okay, you see the students, I have written their statement. Yes, the Coulomb's law in electrostatics. See here, I have written here, it states that 2 point charges attract or repel each other with a force which is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of distance between them. Now, according to this statement, suppose that I have taken here, this is the one charge and another charge I have taken. You can see, you can put the name also. Suppose that here is A and this is the B. A and B, there are 2 point charges that is placed. You can put here, suppose that Q1 charge and here is the Q2. Q1 is placed at point A and Q2 is placed at point B, and having distance between them is, suppose that R. So suppose that if there is these two charges are like, so what will happen? It will experience force, but it will be repulsion. Yes. And if you will say one is the positive, another is the negative, then it will attract. Okay. So according to these statements, we can find their formula also. And this is very important. I think that last classes also, I was discussing that, you know that if you will complete these ones, and this formula also we can use in another chapters, electric fields. Okay. This is important because so many numericals related this one you will solve. Okay, so you see that I have taken here one charge here Q1, another we have Q2. Okay, and what is the distance between them? Okay, very good. So assume that these two charges are placed in a vacuum. Yes, it may be the different mediums. I have taken vacuum or air medium also. Yes. So if you will take these ones, so according to this statement, what we can write here? So I have written here, you see that force, here is a force. Force is directly proportional to the product. Here is a product of magnitude of charges. So suppose that here we have assumed that Q1 and Q2 is, what is Q1 and Q2? Charges. You can write it also here. Okay. Suppose let us consider 2 point charges placed at a distance R in vacuum. Then from definition, what you will write? Anybody? See here, from the definition what we can write? F is directly proportional Q1 Q2. Yes, you can put, this is the equation 1. Also you will write here F is inversely proportional to the square of distance between them. So we have two equations. You can see there are two equations. One, we have F is directly proportional to the product of Q1 and Q2, And next we have F is directly proportional, okay, sorry, inversely proportional 1 by R square. Now we can combine this one. Okay, very good. So we can write here, now combining equation 1 and 2, we get what you write. Left side, here is F and here is F also. So combine this one. So you will write here F and here is proportionality. You can see this one also you can combine. So here will be Q1, Q2. You see that Q1, Q2 multiply with 1. So you will write here Q1, Q2. And suppose that here is 1 multiply with 1 into R square. So here will be R square. Is it correct? Can we write this one? See one more time. We have equation F is directly proportional Q1 Q2. Another we have F directly proportional 1 by R square. Now combine these two equations. I have written that one. Now combining equation 1 and 2 we get. So this we can write here F directly proportional Q1 Q2 by R square. This we can write. Okay. So suppose here is a proportionality and you know that whenever we remove the proportionality, so we have to write any constant because it depends on the medium. Okay. So you can write here F equal to K Q1 Q2 by R square. What is K? K is proportionality constant. Yes. You can write where K is proportionality constant. In SI unit, what is the value of K? What is the value of K? In SI unit, K equal to 1 by 4 pi epsilon naught. So you can put here, then what you will write here, F, if it is placed in the vacuum, then here also you can write vacuum VAC, or air also you can write 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, this is the formula and this gives the Coulomb's law. According to Coulomb's law, we can write F vacuum or F air equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the formula. Or what is the value? What is the value of epsilon naught? Epsilon naught equal to 8.854 into 10 to the power 8.854 into 10 to the power minus 12. Okay, very good. So this you can also write here 10 to the power minus 12 per Newton. That's it. Are you able to see? No. Okay, I will write here. No problem. 10 to the power, it is also unable to see. So I will erase here and again I will write here. Okay. Here you can write. See, yes, I have written epsilon naught equal to 8.854 into 10 to the power minus 12 per Newton per meter square and Coulomb square. And what is the value of pi? You know, pi equal to 3.14. So this value you can put here. This value you can put here. Okay. Then finally you will get this 1 by 4 pi epsilon naught value, or this one also you can write. Okay, students, I think that you should write this one. This is important questions for all. Either only the students, those who are preparing for the board exams, okay, they can also, this is the importance, and those who are students preparing for the JEE mains and advanced, they can also see this one because this is the important questions and related this one, so many numericals you have to solve. Okay, so this is the statement and Coulomb's law states that the 2-point charges. Yes, you will keep it in your mind. Yes, Coulomb's law gives the what is the 2-point charges. Okay, and whenever we place this one in airs or vacuum mediums, then you will get this formula. What is the value of epsilon naught? 8.854 into 10 to the power minus 12 per Newton per meter square, Coulomb squares, and the value of pi is equal to 3.14. Okay, so I think that you should write these ones, or you can also capture. Is it correct? Okay, very good, students. Okay, shall it erase now? Shall it erase? Okay, and also this side I am erasing this side here. Okay, you see. Again, we can put this value. If you will put here, then here will be F vacuum equal to 1 by 4 into pi value 3.14 and the value of epsilon naught 8.854 into 10 to the power minus 12. We can write. Okay, and Q1 Q2 by R square. Okay, this you can write. Now multiply these ones and divide by, okay, this, so you will get F vacuum equal to 9 into 10 to the power 9 Q1 Q2 by R square. So this value is also that you can write. After that, after writing here, okay, after writing this, you will come here. Okay, you will write this one, these two steps. Okay, so this is the final equation, and you can solve so many questions related this one. I will solve. Okay, no problem. You have written all. Okay, so shall it erase the statement? Okay, very good. Now students, and we got the formula Coulomb's law in electrostatics. But how we can find the unit of charge? Yes, units of charge. Yes, we can find the unit of charge, but according to the statement, according to the Coulomb's law, we have formula from Coulomb's law. What is the formula Coulomb's law? F vacuum equal to 9 into 10 to the power 9 Q1 Q2 by R square. This we got. Suppose that, assume, okay, this is the 2 point A and this is the B, and here is charge Q1, here is Q2, and force is experience, and here is force experience with each other. Okay, now if you will assume that Q1 and Q2 having the same magnitude, okay, if Q1 and Q2 will same and the distance between them is 1 meters, 1 centimeter, like that you can take, then, okay, assume, suppose that, or you can let Q1 equal to Q2 equal to Q. Can we write like that? And R equal to 1 meter. Okay, and F vacuum equal to 9 into 10 to the power 9 Newton. Put this value and suppose that this is the equation 1 and this value you can put in equation 1. So what you will write? Show from equation 1. Put this value. Then left side you will write here 9 into 10 to the power 9 equal to, and already here is 9 into 10 to the power 9, and you will write at the place of Q1 you will write Q, at the place of Q2 you will write here Q, and R at the place of R here is 1, and then also you give a square. Okay, power will remain same. So you see that, so these two term will cancel out because both having the same value, and now here will 1 equal to Q into Q square, and 1 square means 1. So you can cross multiply, then what you will write? Q square equal to 1, or you can find out the value of Q. So here will be Q is equal to plus minus what? Root under 1. Plus minus root under 1, or you can also write this one, Q equal to, what we can write? Q equal to plus minus 1, and what is the unit of charge? Coulomb. Okay, very good. So this is the unit of charge. Unit of charge means we can say that when 1 coulomb is that charge which repel an equal and similar charge with a force 9 into 10 to the power 9 Newton when placed in vacuum at a distance of 1 meter from it. Is it correct? So we have Q is equal to plus minus 1 coulomb. This is very important formula we got today, and I think that you should practice these questions. Related this one also, we have to find out the direction. Yes, we will also find out the directions. How we can find out the directions of the force when there will be different or the same charges. Okay, student. Okay, very good. So you will practice these questions. Thank you. Next classes we will discuss more points. Okay, very nice.